Alright, let's have a test review. What are all the pure substances? What is a pure substance? Anyone else suggest y'all to study before coming to test review? What does the word pure mean? All the same. So it's a substance in which everything has all the same part. So a pure substance has a definite composition and includes elements, molecules, and compounds. Describe atoms. What's an atom? Smallest unit of matter, made up of protons, neutrons, and electrons. What's true about an atom? That's one way of wording it. It's it keeps its physical and chemical properties. So one atom of gold would have the same property as a bar of gold. This is only true if the atom isn't bonded to other atoms. So if you just had pure gold, you can break up it into all individual components, separate it out. So if you just had pure gold, every component of that gold bar has the same property. It's another reason it's a pure substance. What's an element? Pure substance? Yes, that's what we just literally said. So, what's an element? It's something made up of only one type of atom. Cannot be broken down into simpler substances. Not by chemical means. You can theoretically split an atom, but that's beyond the scope of this class. So chlorine, gold, O2 would be considered an element, even though it's two oxygens bonded together. Yeah. So what's the difference between a molecule and a compound? No. Molecule is when you have multiple atoms bonded together. So a compound is where you have multiple atoms bonded together. So you have this additional constraint that it has to have at least two different types of atoms. So for example, H2 is a molecule. Sugar is also a molecule, but it's also a compound, and H2 is not a compound because it doesn't have an additional type of atom. So compounds are molecules, so a compound is a molecule, but it has to have more than one type of atom. So all molecules are compounds, but not all molecules are compounds. All compounds are molecules, but not all molecules are compounds. This is a review. Yeah, I have the PowerPoints up there. If you want to go copy it off the PowerPoint, go and find it. This is just me redoing the vocabulary. This should already be in your notes. What's a mixture? What's a mixture? Not element substances is better. When you have at least two different substances, whether or not it be an element and a molecule, or a compound and a molecule, or two different molecules, but they just have to be different. You have two different things combined together that are not chemically bonded. What's a heterogeneous mixture? So yes. So you can see different substances. And what about homogeneous? Appears to be the same throughout. Water is not a mixture. So tea, because it has sugar, it has tea flavor in it, and it has water in it. Yes, trail mix, because you have different components in it. And again, this only includes a mixture. It doesn't include like water. Water is not a mixture, it's a pure substance and only contains H2O. So water is not a heterogeneous mixture, and it's not a homogeneous mixture. It's not a mixture at all. So would table salt be a heterogeneous mixture or a homogeneous mixture? No, it wouldn't. It's a pure substance. It's neither. Again, in order for it to be a homogeneous mixture or a heterogeneous mixture, it has to be a mixture. What's a colloid? So it's somewhat considered a homogeneous mixture, but it's not a true homogeneous mixture. Alright, it's somewhat in between heterogeneous and homogeneous. It looks the same throughout, so it does meet the definition of a homogeneous mixture. However, you can see individual parts if you zoom in very closely. It's where the particles are large enough, the different parts of it are large enough, are small enough that they don't settle out, but large enough that you can actually inspect them under a microscope. How can you test if something is a colloid or a true solution? No, you wouldn't. We also reviewed this yesterday. So how can you tell if something is a colloid versus a true solution? How do you know milk is a colloid and salt water is a true solution? Yes. You shine light through it. If the light is dispersed, meaning that you can see the light in the material, that means it's a colloid. If light travels through it without being dispersed, that means it's a true solution. So true solutions are transparent. Colloids are cloudy. What's a suspension? Uh, the suspension will eventually settle. However, it will briefly stay dispersed. So what are some examples of suspensions? So flour and the dust in the air, flour and water. Flour can't dissolve in water, so it will eventually go out. So another definition of a homogeneous mixture is where one material has dissolved in another. Flour is insoluble in water. However, if you stir it up very well, the flour will briefly stay in suspension. Given enough time, it'll separate out. You can have sand and water. The mixture still is undissolved. It will eventually settle to the bottom with some particles still floating. So it's when the solid does not dissolve, so muddy water. It's containing sand, so sand doesn't dissolve in water. We wouldn't have beaches. What's some other examples? So some other examples. So salad dressing when you shake it up. Orange juice if you have pulp in it. So if you have pulp and orange juice, the pulp is going to eventually settle down to the bottom. The pulp doesn't dissolve into the liquid, right? It doesn't disappear. So you still have solid floating around, and that's solid doesn't dissolve into the liquid. A lot of medicines, a lot of paints. Paints usually have some pigment in it. That pigment doesn't dissolve. Snow globe, when you shake it up, the snow, wherever that material is, doesn't dissolve. So suspension is where the material doesn't dissolve into it. So another reason why colloid isn't considered a true solution, because the particles aren't dissolved into the material. So suspension is a mixture in which insoluble or soluble particles are suspended in it. They will eventually settle out. Let's see. I have to be careful. Yesterday, by the way, don't Google bronze statue. There is no bronze. Luckily, it wasn't displayed here. But I googled bronze statue to show the other class what bronze looks like, and every single statue is of nude people, and usually it was fertility statues. What would this be? So we have fruit and gelatin. The fruit isn't dissolved into it. Yes, this is heterogeneous. It's not a suspension. So even though the particles aren't dissolved into it, they aren't truly dispersed everywhere. We can clearly see where the strawberry is versus where the other berries are. We can clearly identify the different parts. Whereas in a suspension, whenever you mix these, you can't really tell where the flour particles are versus where the water particles are. If you were to pull it out and just try to use your fingers to separate it, it would be very difficult. Impossible, because the particles are just super tiny. Here they're moving around too much. And it's still cloudy, so this is a suspension versus like a this is heterogeneous mixture, because you can clearly see the parts. They won't settle out. Gelatin has hardened, so you won't settle out. But if you have sand and water, the sand will eventually settle out. So will the flour and the. What would whipped cream be? What is whipped cream? So what'd you say it was? You would call it a solution? So what is whipped cream? Why does it get all fluffed up? How are you able to take and pour all of this cream into this can? And why does it, when you spray it out of the can, does it puff up? Kinda. Not really. Let's see if I can find a definition. thought everyone would know what whipped cream was. So whipped cream with the Alright, so whipped cream is a cream that is whipped by a whisk or mix, caused by an expansion of dissolved gases, forming a colloid. Depending on how whipped the cream is, it's either a heterogeneous mixture or a colloid. Like, this would probably, because you can't really tell it, this would probably be closer to a colloid. A lot of times you would almost consider it heterogeneous. The reason why is whipped cream traps nitrogen. So that can of whipped cream is filled to the brim with nitrogen. It has a gas in it. You could also use CO2, but you don't want to use CO2 because it will ruin the whipped cream. It'll react with the whipped cream, turning it brown. And you don't want your food to be reacting and decaying and rotting and doing whatever you want to be preserved. Nitrogen doesn't react with anything. And so what happens is when you spray it, you have a high pressure of nitrogen, and that nitrogen, once it goes into lower pressure, will expand out. So whipped cream is little tiny bubbles of nitrogen. I think it's nitrogen. Let's see. Where's the gas? Nitrogen oxide. That's it. Laughing gas. Carbon dioxide tends to give it a sour taste because it reacts and turns into an acid, carbonic acid. The reason why Coke is slightly acidic is because your Cokes have CO2 dissolved in it, which gives it a slightly sour taste. But it has a lot of flavoring and sugar in there, so you don't taste the sour. But it turns into an acid. They put nitrous oxide in. So this is a mixture of cream with tiny bubbles of nitrogen oxide. So it's a mixture of nitrogen oxide and cream. Then when the goat reaches into the air, what happens when you lower pressure? Volume goes up. So the volume of these little bubbles increases. Because the bubbles don't settle down, you could consider it a colloid. But have you ever left whipped cream sitting on a desk? So there's the issue is if you put it in cold, it'll stay as a colloid. But if you put it in warmer temperatures, have you ever seen whipped cream after it warms up? What happens to it? So the gas is able to fall out of suspension. So depending on the temperature, you could either keep it suspended, which would make it a colloid. At room temperature, though, I would say it's more of a suspension. Note that because it's a gas, instead of the gas falling down and settling at the bottom, the gas rises up. So this trapped gas will eventually come out of solution or come out of the mixture, and it'll flatten down. So I would classify whipped cream as borderline suspension colloid, depending on temperature. As temperature goes, I mean, it's often considered a heterogeneous mixture. It would be fair to say it's a colloid, though. It is most definitely not a solution or homogeneous. The key thing is it's not homogeneous. What would gelatin be? So let's ask ourselves the question. Let's see, where's that flow chart? Yeah, just pure yellow. Pure yellow. One of these PowerPoints had a flowchart on it. Or maybe that was just have you ever shined light through yellow? Let's look at a picture of depending on what is mixed into it, typically would be considered a solution. It looks the same throughout it, and is mostly transparent. Yeah, I think that's the next thing. So it does disperse light a little bit, but not that much. For the most part, it's clear. Depending on what food you can add to it. So does water have the same properties as hydrogen and oxygen? Can you breathe in water to live? So they don't have the same properties. So when molecules are bonded together, they have their own unique properties, different than their components. Uh, so let's say that you have salt water. Can you break apart? Can you set? So salt water is what type of substance? How would you classify salt water? What type of mixture? Homogeneous or solution. So it's a true solution or homogeneous mixture. How could you separate the salt from the water? So is boiling a chemical process or a physical process? Phase changes are physical. We've already learned that. Yeah, unit on that. I think we had 2 units talking about that. So you can separate a homogeneous mixture by physical means. What if you wanted to separate water or H2O and the hydrogen oxygen? Can you boil it or do some other physical mean to do that? Can you use a filter? How can you separate water into hydrogen and oxygen? Electricity. But can you do it using physical means, such as filtration or boiling or some other physical process? So to break a molecule into its parts, or to break a pure substance up into its parts, you have to use a chemical means if its molecules are compounds. Can you break up atoms, though, into exponents? Can you break it up into protons and neutrons? Not using chemistry or physical means. But you can break water up using chemical. So if you wanted to put more CO2 into your drink, what could you do? So let's say that you bought one of those fancy machines where you make your own Coke. You add your flavor, you have some CO2 cans. How can you get more CO2 to dissolve in your drink? How can you get more CO2 to dissolve in your drink? Nope. No. Lower the temperature. Or you can do what? You can lower the temperature to get gases to dissolve. Or you can increase the pressure. For gases, yes. Buck's not even chemistry and getting it. Oh, that's irrelevant. Let's see where. So remember when looking at the graphs, you can tell which one is a gas because as you increase temperature, the solubility decreases. For gases, you have to decrease temperature for the solubility to increase. For solids, it's the opposite. For solids, as you increase temperature, more can dissolve. So factors that affect solubility is temperature. This nature, like dissolves like. What does that mean? What does like dissolves like mean? It means that polar molecules can be dissolved in polar. So polar solvents can be dissolved in polar solutes. So water is polar, sugar is polar, so sugar can dissolve in water. Oil is nonpolar, so oil and water is polar, so oil cannot dissolve it in water. So polar dissolves polar, nonpolar dissolves nonpolar. What does unsaturated mean? What does non-saturated mean? No. Means that more solute can still dissolve. It contains less than the maximum concentration of solute. Contains less than the maximum concentration. What does saturated mean? Means if you add any more solute, it would not dissolve in it. So it's at the maximum amount of solute that can be dissolved. It's also at equilibrium with it. What that means, whenever you're saturated, what's going on? So if you put a lot of salt or sugar in the water, so if you put a lot of water, you have these particles. You'd have like salt or sugar particles flying around, and you'd also have them sink down to the bottom. If you add more solvent or more solute, so if you add a lot of sugar to some water, some of it it's only so much can dissolve into the liquid before the rest of it settles to the bottom. We say that this is at equilibrium because some sugar at the bottom will go into solution, forcing some to come back out. And it'll be a constant amount that falls out of solution and goes back into solution. So to be saturated, you're at the maximum amount that can be dissolved, and it just sits there in equilibrium. And what is supersaturated? Bless you. What is supersaturated? So it's when you force more than what is maximally able to be dissolved to be dissolved. And how can you achieve that? So raising the temperature and then doing what? And then slowly reducing the temperature. If it's rapid, then it's unstable and fall out immediately. What is the equation for molarity? Yes, mole solute over liter solution. What does solute mean? And what does solvent mean? Yes. And solution is the combination of both, a mixture of both. What is the universal solvent? solvent. What is an alloy? So it's a mixture of two different types of metals. It's a homogeneous mixture of two different metals, which means it's a solution of two metals. So periodic table. Do you see bronze anywhere on this? So it's not an element. If it's not an element, you have to ask yourself, is the two metal, so it has to be a combination of metals. Next question is the two metals chemically bonded together? And the answer to that would be no. Because you can separate, so let's say you had a gold ring that's not pure gold, it's a mixture of, it's an alloy of copper and gold. Y'all know how y'all separate the copper from the gold? Different melting points. You can heat up the gold ring and melt the gold or copper out of it. Technically what you would do is they also have different densities. You would liquefy both. And then you would reduce it so that you're at the temperature so one solidifies and the other one is still liquid. And so what happens is you'll end up with two liquids, one of molten gold and one of molten copper. Because they're at different densities, they'll separate out. And then you can reduce the temperature so one solidifies and one's liquid, and then you pour off the liquid. And now you hit. That's how they separate two different metals. Technically, a more advanced, I don't know if they, one way of doing it is distillation, where you boil the metal, but that's crazy high temperatures. They would separate it into pure gold, and well, how they do it is chemically. They would melt it, and no, they would put in an acid that physically. So again, remember that if you have a homogeneous mixture, the different components retain their same properties, right? So if you have a mixture of gold plus copper, the gold atoms are going to retain their ability to be gold. The copper atoms are going to retain their ability to be copper. And if you had an acid that only dissolves copper but not gold, if you put in a gold copper ring, the acid would dissolve all the copper, but the gold would sink to the bottom. That's how they really separate the gold out. Is they put it in sulfuric acid or some material that doesn't dissolve gold. Because it's a mixture and they're not chemically bonded together, the atoms have different properties. But an alloy is a solution or a homogeneous mixture. What would mayonnaise be? It's not homogeneous. It's a mixture of water and oil. And it wouldn't settle because it's an emulsified thing. It's because it turns into solid. If you were to liquefy it, it would eventually settle. It would be the oil and the other stuff. It would probably be it'd be suspension. So mayonnaise is technically would be a suspension too in that case, because it's solid at room temperature or solid-ish. It retains its shape to some degrees. Not true liquid, and you can still pour it. Uh, it's not quite solid, but it would be considered heterogeneous. Probably need to replace that. That's too confusing, y'all. Gelatin's right on the line too from being a colloid because it's kind of cloudy, like gummy bears. Kind of cloudy. Main thing is remember, can you see individual parts? If you can see individual parts, it's most definitely a heterogeneous. Will the parts settle out over time? Then it's most definitely a suspension. If it looks the same and is transparent and clear, and it has at least two different things like salt and water, it's most definitely a solution. If it's cloudy and light is scattered, it's probably a colloid. I'm probably going to reword some of these questions or some of these answer choices to make it more clear. Because some of them are right on the line on how I have it here. I'm going to make it to where, I'm definitely going to change one of these. I think last year what I did is if you chose either of the two answer choices, I most definitely, I counted it right. Because this again is a gradient scale. And then I'll have some problems like the curves. I'll ask you if this is super saturated, unsaturated. What is the solubility at blah, blah, blah. But it sounds like I'll definitely need to study.